Hello everyone, good afternoon to all. Dear authors and invited guests, welcome to Technical Session 8C. Myself, Harsh Soni, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and JR Scholarship LLP, it is my great pleasure to welcome you all to the 9th International Conference on Information and Communication Technology for Sustainable Development, ICT4SD 2024, Goa. The 9th edition of this conference is being organized in a hybrid mode. Physical event is organized yesterday in Goa, that means 8th August, and the virtual event is being held today and yesterday, that means 8th and 9th August 2024. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 10 presentations, and each presenter will given 10 minutes for the 8 minutes for the presentation and 2 minutes for the question and answers. That means total 20 minutes per person will get. On 7 minutes, I will raise a gentle reminder so that you can conclude your presentation on time. And if you have any query or any update, you can write it to me directly in the chat box. And there's another request to all the authors that you may please stay connected with us till the closing remarks so that we can capture good memories of this virtual conference. So moving forward, just before we start the session, I like to introduce you all the chair for the session. So I'd like to invite Dr. Ranjit M. Gawande, and he is going to chair the session. Dr. Ranjit is currently working as an assistant professor at Matoshri College of Engineering and Research Center, Nashik, India. He is an experienced computer faculty with demonstrated history of working in the education management industry. He is skilled in data analysis, C++, Linux, Ubuntu, and research. I welcome you all. Welcome, sir. If you have any remarks for the authors.
Yes, please start the session. We are
Okay. So, starting the papers, first we have Anaswara Murali, and she is going to present on analyzing the customer sentiments towards hybrid cars. Dear Arthur, are you available?
Hello, sir. Am I audible?
Yes, you are audible. You may please proceed with your presentation.
Hello, sir. Can you just confirm if the screen is?
Yes, your screen is visible.
Okay. So, hi everyone. A very good afternoon. So, I'm Anashwara Murali. I'm going to present on the topic analyzing the customer sentiments towards hybrid cars. So, the Indian transport industry faces a critical turning point and faces several barriers in terms of growing environmental concerns. So, these problems are also include increase in the cost of petrol and how it is important to switch to sustainable mobility solutions. So also Indian customers become more and more conscious about the environment as a result of air pollution and climate change, as vehicle pollution is considered one of the most significant contributor in environmental pollution. So, so several approaches need to be done for the approach to conduct a thorough investigation into this consumers' opinions regarding what hybrid electric cars. So the utilization of a research approach integrates quantity surveys and various sentiment analysis over the internet data can be used, and the Indian automotive industry stakeholders and different people who are connected with the industry can benefit from this study. So the main objectives of the study includes to understand what are the challenges faced by the customers of hybrid cars. And also the second one is to identify the key sentiments, like what the customers are feeling, by analyzing the online reviews to identify and categorize key sentiments expressed by the customers towards the hybrid cars, and also give suggestions on that. So for the study, we had taken previous literature work, and it was able to we were able to find out that the previous work, including the factors influencing the adoption of hybrid electric cars, they did a consumer behavior analysis and the key findings were their environmental concerns, economic benefits, and social influence are key motivators of hybrid electric vehicle purchase intent. Another study done on consumer perspectives on hybrid electric vehicles, they did segmentation analysis, and it was identified that distinct consumer segments based on the attitude towards hybrid electric vehicles. Influence of consumer knowledge on perceived electrical vehicle characteristics. They did a survey and analysis, and consumer knowledge impacts on perceptions on electrical vehicles were found out in that study. Another study included influence of electric vehicles, charging infrastructure on market diffusion, lessons learned from the Northeastern United States. So it was a case study analysis, and charging infrastructure was a concern. So it influenced the market and the diffusion of electric vehicles. So another thing is a hybrid model for sentimental analysis of reviews for new energy vehicles. So a machine learning approach was used over there, and they developed a novel hybrid model for sentiment analysis of new energy vehicle reviews. Another one is development of hybrid electric vehicles, a history of perspective. A historical analysis was done in that they explored the historical development of hybrid electric vehicles from a technological perspective, and federal and state incentives for electric vehicles and charging infrastructure. So policy, the US Environmental Protection Policy Agency had given a paper, and so that was also reviewed. So overview of the federal and state incentives of EVs and charging infrastructure in the US was could be found out using that. So there are various other literature review that we took also. So going on to the research question. So what we found out was that what we intended to find out is that what are the consumer opinions on hybrid cars based on online reviews, and which features are most desirable and most important to the customers. So the methodology that we employed was that we collected data from popular Indian hybrid car review websites available online. Like a total of 2,000 reviews were gathered from these websites for an analysis. The reviews of the customers were taken along with the ratings, 5 being excellent, 4 being very good, 3 good, and 2 poor. So the data collection, was done, and then the collection, the data set was useful to learn about the consumer attitudes and preferences in the car sector. Then a sentimental analysis, we pre-process the data and we clean the data, all the things, all the methods for leaving out the null values and doing all that was done. And for the sentimental analysis, we use the Python NLTK package. The sentimental analysis has been done on the text reviews. So a Python module, which was called NLTK, it was keeping up with the Python's development to meet the demands of the researchers and educators in both the natural language processing. So the data set generation was done, pre-processing was done, and then the model was trained. So scikit-learn module was used, which provided which provides easy to use machine learning models in minimal code, and in support vector machine algorithm. So that was used. So after training, we used the same instance for testing, and the results were saved. So we use naive bias and support vector machine algorithm. So after that, the testing was done, and then the trained machine learning model was used to classify the data. Also, we did Another one like we did was doing a word cloud generation. That was also we used the NLTK program to build word clouds to show commonly used terms in positive and negative evaluations. So the key findings that we were able to find out was that the
Sorry to interrupt
positive.
you, Avtar, but you have last 1 minute.
Okay. So we were able to find out that the majority of consumers were positive and indicating a favorable perception of hybrid cars, and also negative was 25%, so a significant portion of the review were negative, highlighting some of the concerns that was dissatisfaction. The neutral segments were 15, which was offered a mixed review on that. And the main key positive aspects were the fuel efficiency, environmental impact, and technological innovation. The key negative impacts were high initial cost and maintenance cost, also the charging infrastructure. So this was the word cloud using Python, and that was a positive word cloud, and this is the negative word cloud that we got from the analysis. So to conclude, I would like to say that to encourage the use of hybrid cars, it is more important to focus on the benefits like the performance and also the environmental effect and the fuel efficiency and safety, etc. So companies and the various stakeholders should adjust their strategies based on what people think about hybrid cars, and continuous research will help to understand changes in the consumer opinions and support efforts to promote eco-friendly transportation in India. So these are the references. Thank you so much.
No,
So
sir,
any
is there any
questions from the
question?
audience? Any questions from the audience? So, Miss Murli, you have chosen very good topic for your research purpose.
Thank
Uh,
you, sir.
can you tell me what kind of data set you have used for that one? Means it is being available anywhere, or you are being creating the data set?
Sir, what we did was we had a set of like online reviews. Like we had taken many like Indian hybrid car websites. Like there were sites like Car Dekho, Car Wale, and
Okay.
YouTube
So,
reviews,
have you
etc.
downloaded it?
We had taken all the data, we scraped the data, and then we used it, we saved it in an Excel file and used it for the analysis.
Okay, very good. So, it is basically a text data, na?
Yes.
And it is not being clear from your system architecture whether you are going with the supervised learning or the unsupervised learning.
So that we were going for supervised, because it like qualitative data was converted like based on the sentiments of the sentence using that NLTK module. So based on that, we found out how it is done.
No, what I would like to suggest, because the data is in a form of the reviews, is that correct?
Yes, yes, sir.
So it is being text data. So I recommend you or suggest you to go with the unsupervised approach.
Okay, sir.
Because what happened, suppose you are being segmenting the data and being creating the nodes for that one and creating the tables for that, then it will better to go with the supervised learning, and you have a very bright chances. But the data set is not available in a tabular format, structured format. So my recommendation is
Yes.
you have to go with the unsupervised learning.
Okay, sir. Yes.
That's all my from my side.
Okay. Okay. Thank you for your valuable presentation.
Thank you, sir.
And I request for the next presentation that Sherin Mariam is going to present on automatic subjective assessment using natural language processing and machine learning. Dear presenter, you may please proceed with your presentation.
My screen available?
Yes, it is available.
Okay. So good afternoon all. I am Sherin Mariam George, research scholar from CVM University, Gujarat. And my co-author is Dr. Narendra Singh Chauhan. I am going to present my research topic regarding automatic subjective assessment using natural language processing and machine learning. And my paper ID is 231. These are the contents: introduction, challenges in automation, methodology, experiment and result, conclusion, future work, and references. First of all, introduction. Around the globe, the assessment of subjective answers play an important role in the education system. So this type of assignment help to evaluate the performance of a student to a certain extent. But the traditional way of human evaluation method have some shortcomings, like it may be tiresome, arduous, it may be expensive, and it requires the knowledge of teachers, and it takes too much time also. So which make it less practical. So over the years, researchers are putting their efforts on automatic assessment of descriptive answers, but this research is still at its infancy stage. Now, about the challenges in automation. First of all, the challenge facing is it is very difficult to recognize the natural language answers. And second challenge is considering the semantics is a complex process. And third challenge, the answers may vary based on the vocabulary used by the students. And the last challenge is using a machine. It is essential to feed the human intelligence of understanding the concepts of answers. So about the methodology we have applied, by analyzing the outcome of different research papers, we have designed a model that includes different NLP, ML, and deep learning techniques for the automation of descriptive answers. So with the help of proper data set and word embedding, we need to mitigate the challenges in automatic subjective evaluation. So the proposed method designed in such a way that it checks the similarity of sentences in terms of semantic, lexical, and conceptual ways to achieve the accurate result. So this is the proposed methodology. We have used semantic text similarity data set, and this data set contains 8,630 records, each containing pair of sentences along with the human annotated score ranges from 1 to 5, 0 to 5. So normally this data set contains almost single sentences. First of all, we have applied the text pre-processing step. So one of the crucial steps in preparing document for similarity measurement is text pre-processing, which can improve the result of the accuracy of the result. And here we have applied the pre-processing steps like tokenization, stemming, lemmatization, stop word removal, etc. And we have extracted the keywords from the sentence pairs using keyword extraction algorithm like keyword. There are so many keyword extraction algorithms available like EAK, RAKE, KPMan, etc. But we have selected keyword, and then we have applied the similarity measures like cosine similarity, Jacquard similarity, keyword weightage, wordnet score, fuzzy similarity, and even we have used the sentence transformer that is available in Hugging Face. And we have developed our regression model using the support vector regression model. And finally, we have evaluated and tested our model using the regression evaluation measures like mean square error, R2 score, and root mean square error. And we have calculated the final score of answers based on 6 factors like keyword weightage, cosine similarity, Jacquard similarity, fuzzy logic, wordnet similarity, and sentence transformer score. And each factor is scaled down from 0 to 1. And this is the formula for predicting the final score. Final score is equal to keyword percentage into weight of keyword percentage plus cosine similarity into weight of cosine similarity plus Jacquard similarity into weight of Jacquard similarity, wordnet similarity into weight of wordnet similarity plus fuzzy score into weight of fuzzy score plus transformer score into weight of sentence transformer score. And this is the data set we have used. This is the information related to the data set, and it is available in some eval 2017 data set, and it is available in the Kaggle also. And the data type is textual and numerical, and it is available in .csv format, and it is open access. Now, about the result, comparison of scores obtained through similarity measures. Here we have applied several similarity measures like keyword, cosine, Jacquard, Werner, fuzzy, and transformer, and it is compared with the manual score. So by looking into the score, it is clear that keyword and Werner similarity is more. Then these are the different weightage factors that is given to each factor. We have given more weightage for keyword, cosine, fuzzy, and sentence transformer. And this is our comparison of score between manual and model score. And this is the final performance evaluation. We have used the regression evaluation parameters like R2 score. We got 0.724, then mean squared error 0.024, and RMSE value 0.15. Then, in conclusion, in this research work, we have applied a combined approach of machine learning and natural language processing to automate the evaluation of subjective answers. So a framework of subjective assessment, it includes a lot of steps like pre-processing procedures, several keyword extraction algorithm, text similarity steps, then numerous steps for final score prediction, and regression models for evaluation. And finally, we found that the feature importance score of keyword percentage and Werner similarity is more important compared to other factors, and assessment is predicted using the support vector regression model. And about the future scope, the proposed methodology integrate various NLP and machine learning techniques effectively, offering a structured approach for automatic grading. And here we have used the semantic text similarity that consisting of single sentences, but we need to explore more benchmark data set like Mohler data set, where we get different type of questions like definitive, conceptual, analytical, and short answer, and their corresponding human evaluated. So although the method giving good result of single line sentences, but we need to explore the diversity of question and answer types that eventually consider the ethical implications of automated grading system, such as fairness, transparency, and privacy. And further, we need to explore recurrent neural network based models to automate the evaluation of descriptive answers. And these are the references. Thank you.
Thank you, Ms. George. Uh, is there any question from the audience so that we can fruitful discussion about? Otherwise, it will be a monotonous. I will ask the question. Yes, Mr. Jain. Any other participant? So, Ms. George, basically your area is text, means whatever the input
Text
that will be a
analysis.
text.
Text analysis, sir.
Yeah. So, apart from that Jacquard similarity, you have chosen few other techniques for checking the similarity within a text.
Yes, sir.
So, how do you finalize these techniques? Means why you
Actually,
have chosen?
I have explored different similarity measures like cosine similarity, some different research papers.
Mhm.
I have explored different measures and try to include all these concepts in this paper and just find out what will be the differences in the comparison of score between manual score with the similarity measures.
So, have you experimented with them and then
Yes, sir.
rejection is
Yes, sir.
possible?
I have experimented. I have experimented it.
You have experimented and then you have decided to go with the Jacquard and whatever you have
Jackward
selected.
and yes, sir.
Yeah.
Because keyword percentage is more important in subjective answers.
Okay. So basically, I understood from your presentation that NLP playing a major role, but I
Yes, sir.
couldn't recognize what exactly the role of machine learning. Whether you are just using the neural network from the machine learning domain or something else?
Actually, now I have applied just only regression model, but my
Sorry.
future scope is to currently I have just evaluated with machine learning models only with a simple regression model, and now I am going to explore more into recurrent neural network
Okay.
like LSTM by LSTM, GRU. Likewise, I will explore. That's my future scope, sir.
Okay. And you're basically the output is means you
Output
are
is
again comparing with the manual again.
manual evaluation technique, manual subjective evaluation techniques.
So, is there any benchmark model from which
Yes,
you are?
regarding benchmark data set, actually one data set is there, Mohler data set, but the size is also very less. So we are trying to create our own data set by conducting subjective quizzes from question students. Likewise, we are creating our own data set.
Okay.
To increase our data sets, we are creating our own data sets.
Okay. So one last question from my side. What is your objective for creating this? Means what is the aim of your project?
To analyze the semantic similarity, to check the semantic
No,
similarity.
but for whom?
Means initially we are planning it for subjective answers, and this can be applicable for many type of applications like information retrieval case, then recommendation system. Means where we can apply semantic similarity purpose, we can use these methodologies
What I recommend
to
you,
find the.
why not you go with for reviewing the papers? Means what happened? Many reviewers comment on the published paper
Okay.
during the reviewing process.
Okay.
So there is a scope to apply your model for reviewing process of the
Yes, sir. Yes, sir.
research
Thank you.
paper.
Good suggestion. Yes, sir. Yes, sir. Very nice
Okay.
suggestion.
Thank you.
Okay, sir. Thank you. Thanks a lot.
Thank you, dear presenter, for this valuable presentation. And now moving forward to the next presentation. Next, we have Aneri Pandya, and she's going to present on deep learning for breast cancer classification, a comparative study of pre-trained CNN models. The author, you may please proceed for the. And I do one thing. I will conduct next presentation. Till then, you can solve your issue with the mic, right? So that will be okay, I think so. Okay, I'm going to announce the next presenter's name. Till then, I request Aneri to solve the issue with your mic. Next, we have Srinivas Surpur, and he's going to present on efficient text summarization with hierarchical neural autoencoders. Dear presenter, you may please start your presentation.
Hello, good afternoon, sir. I am Srinivas V. Surpur, and my title of the paper is Efficient. Hello, I am audible, sir.
Yes, you are audible.
Yes. My title of the paper is Efficient Text Summarization with Hierarchical Neural Autoencoder. Introduction. We focus on enhancing the text summarization for faster content or understanding. If we give a big or a long text, we waste a long time and in reading those lines and paragraphs. Instead, we use text summarization to justify all the content of that. In this model, we have used a LSTM and a hierarchical LSTM we have used for better data capture, and components encoder, decoder, and funnel network. Funnel network is used to link between encoder data and the output of the decoder data, and the text pre-processing and transformer we have used a T5, and loss function sparse categorical cross entropy, and optimizer RMSE root mean square error propagation we have used. And this is the literature survey. We have surveyed this we have surveyed 14 papers for our research paper, and these are the terms and models we have used in this research paper. And autoencoder is used to learn efficient representation of a data. And in this, we have used a three-layered LSTM model with RNN architecture. RNN means recurrent neural network, and LSTM means long short term memory, and loss function is sparse categorical cross entropy, and root mean square error propagation for optimizer, and transformer is used for extracting the text. By training LSTM model for 17 epochs for the dataset Amazon Find Food Review, this dataset we have chosen from a Kaggle, and this is the pipeline for our problem statement. First, uh, text summarization is done, and then when we give a text input, then tokenization may occur. Tokenization means in we give a paragraph, it breaks down into sentence or uh, lines. Then text standardization is done. Then data split is done. Data split in the train and test. We have we have divided into equal proportion 50% and 50%. Train and the data, we have used three-layered LSTM model and transformer for extracting the whole summary. And in methodology, we have understanding the text summarization means text summarization is a long process that produces a short but meaningful summarization. And in understanding text summarization, there are two text summarization. One is abstractive text summarization, another one is extractive summarization. In abstractive summarization, it generates a fully new sentence from a original sentence. In that extractive sentence, what abstractive sentence is generated, that extractive text summarization means it extracts only important or meaningful sentence or words from that abstractive text summarization. In text pre-processing process, it removes all unneeded symbols or words or other elements. In maximum length, we declare a maximum length that in that length only your text should be uh, in maximum length. You are, you have declared we have declared a maximum length for a text what we have. Sorry, sir. Hello, I'm audible, sir.
Yes, you got it.
Oh, uh, ma- for maximum length, we have declared a length of six threshold value. For that, for that much only word, it includes that words only. It includes and data split, train and test data, abstract to text summarization. In abstract to text summarization, there are four steps. One is the return sequence, second one is return state, third is first state, and last one is layered LSTM. In return sequence, we have mainly in return sequence we are mainly building a sequence to sequence model in a return sequence. And a return state, it when we use a beneficially final state of the LSTM model, set the return state. And first state, in the first state, uh, i- in the first state, internal state of the LSTM are initialized for the first step time. And a layered LSTM, multiple layer of LSTM, one stacked on top of each other, so that sequential representation more better and informative. And so sequence to sequence converter means it converts a sequential number to when in a text we give give a numeric value to the sentence or word that converts in that numeric sequence, it converts into word. And the T5 based transformer is mainly used for summarization of that pre-trained model through three-layered LSTM. I have chosen one Amazon find type food data set. From that one, I have taken one example. First dish name, then tokenization. Tokenization means it divides into words, And encode is means input. We are giving a vegetarian pad, thai, soybean, thai. These are the words that we don't know, or these are the words from another country, or uh, you think you don't know these words. Then encoder gives input to the decoder. Encoder encodes that words into a useful or meaningful sentence or words that that are understandable by humans or computer. Then decode. Then in decode, when encoder gives the input to the decoder, decoder output is vegetable noodles or Thailand style. Thai means Thailand style. Soya beans means bean sprouts. Thai means Thailand method. Or tang tofu means spicy and sweet. And noodle delight means rice noodles. We can understand these dishes uh, completely or understandable. These we have I have got these waveform by training the model to 17 epochs. We have got the result at 8 epoch only. Uh, Training loss means training loss is 1.9751 for 8 epoch, and validation loss is 2.08. Our accuracy is 98%, and x-axis is epochs, and the y-axis is loss function. When it comes to encoding input text and producing summaries, LSTM model work well, especially when it comes to identifying long dependency sparks, long dependency. Sparks category loss, entropy loss is used to gauge the summary correctness. The sparse category loss, entropy loss means it it measures how difference is predicted summary from accurate summary. Then LSTM model have the ability to handle uncommon by either better simulating their occurrence or substituting them with a more widely used synonyms. Further, we in future LSTM and transformer hybrid can be done.
So, Srinivas,
Yes, sir.
you are doing the research somewhere, or you are studying in?
Sir, I'm studying BBB, sir. Now I'm pursuing seventh sem in BE Electronic and Communications.
Okay, very good. At the initial stage, you have taken a lot of efforts.
Yes, sir.
How do you come to define the 17 epochs for your training the RNN model?
Sir, I
Why
have
you have chosen
researched.
17 exactly?
Sir, I have researched some papers, sir.
Mhm.
From that paper, I have uh, almost all they have took 17 epochs.
No,
So
others they have done. That's why you have also used the 17 epochs. It is not necessary. You have to
yes,
experiment it on the various number and
yes,
trying to see what exactly the loss function playing role in creating the accuracy. Okay,
yes, sir.
so it should be minimize the losses in training as well as in a validation.
Yes, sir.
Uh, so experiment it on instead of only stuck with the 17, go with the 12, go with the 21, trying the various inputs model.
Yeah, okay, sir. It may
And
that
have you heard about
uses
the
heavy.
Gemini? Have you heard about the Gemini, Bard, or Bing, or the Chat GPT?
Yes, sir. That
Uh,
uses a transformer T5 base.
okay, so
Yes, sir.
how do you compare your work with them?
Sir, I have worked.
Means your
They means
results should be better than the existing model, na?
yes, sir.
So that the
I have mainly done for
summarization
only
should
taxum.
be improved.
Yes, sir.
So accordingly,
Uh,
you thought about it
no,
and
not
studying their loopholes, whatever the things they are using. If
Yes,
there is
sir.
any loophole or research gap you found, then
Yes.
you can work on it.
Okay, sir. Definitely I will.
At the initial level, you have taken a lot many efforts. I congratulate you specially.
Thank you, sir.
Okay, that's all
Oh,
from my side.
okay,
Any
sir.
other
Thank you.
question from the audience? They can ask.
I believe there's no question from the moving for the next presenter. Next we have Aneri Pandya, and she's going to present on deep learning for breast cancer classification, a comparative study of pre-trained CNN models. Aneri, are you ready?
Yes, am I audible?
Yes, you're audible.
Is it visible?
Yes, now it's visible.
Okay. So good afternoon, everyone. Myself, Aneri Pandya from Charuset University, and today I am giving the presentation on deep learning for the breast cancer classification, a competitive study for a pre-trained CNN model. So basically the introduction, if we talk about the introduction, then the breast cancer is nothing but it is a leading cause of among the of death for the woman globally, and around 2.3 million cases were recorded each year. If we go for the standard scanning method, then the failure rate is very high, which is 4% to 34%. So the alternative of the screening method is nothing but to use a machine learning technique, which is being explored for a better accuracy. So basic objective is nothing but evaluate a pre-trained CNN model for the breast cancer classification for a mammogram images using a transfer learning, and fine-tuning and identifying the models with the highest accuracy using a transfer learning and the best classification accuracy. Now, if we talk about the history, then in 2012, with the introduction of AlexNet, a deep convolution neural network developed by the Alinsky, and the Alinsky impressive performance will give the better exposure, and the success will give a wide area or a wide interest in a research for a deep CNN. Now, today image classification models are more accurate and effective, and the application spacing various like it will cover the domain like medical imaging, autonomous driving, or even image capturing or image classification. Now, let us talk about the pre-trained network and the transfer learning. So basically, pre-trained model is a machine learning model that has been previously trained on a large data set and serve for the future use. And this model can be used for the starting point for a new task. And it will allow a user to leverage the knowledge, and it will be already learned. So pre-trained model are instrument in transfer learning, where the fine-tuned on a small or task-specified data set to achieve a better performance. And the transfer learning is nothing but it is a machine learning technique where the model developed for a particular task is reused as a starting point for the second task. And this approach will give the knowledge, or it will gain from the first task, it will get the knowledge from the first task, and it will improve the performance for the new task. Now, this is the table where we have compared the pre-trained model and a transfer learning with different aspects or in terms of different points like definition and concept, its advantages, pre-trained models and their applications. So the advantage of there are it will reduce the timing, it improve the performances, and it will use the resources effectively. The pre-trained model, we have used our VGG16, ResNet 15, Insertion V3, and ResNet 121. And the application for the medical imaging is nothing but the breast cancer detection and its early diagnosis. Now let us talk about the transfer learning work. So the image will give, we have taken the data set of images for the different image, Now, the first pre-trained model will learn the feature or it will identify the dog. So from the large data set, we can identify the dog and the other images. Now, for the second stage, we are using the pre-trained model, which is previously trained for the dog. And we are including a new task or new trained model for the cat. So after the output of the transfer learning, we can identify dogs and cats differently. So basically, pre-trained model at the lower layers will capture the generic features and it will retain. Whereas for the higher layers, they can adjust or replace for the better use or a task. So this approach will give a pre-existing knowledge in a pre-trained model, and it will reducing the training time and improving the performance on a targeted task. Now, this is the detail for the data set where we have taken the data set which contain the patient record from 1984 to 89 from the German breast cancer study group, where the 720 patient with node positive breast cancer, and it retrained the 686 patient with a complete data. Now, they are being observed for 11 variables like patient age, patient tumor size, patient identification, and likewise. Now, these are the hyperparameters where we have compared the pre-trained models for the same values of activation function, optimizers, loss function, matrix, and the epoch, where we are keeping the number of layers varying for the each and every pre-trained model for the battle output. These are the results after the F1 score of models across the 3 optimizers. And from that, we can identify that for F1 cross is an important metric for evaluating a medical diagnosis, where there is a significant case of imbalance and rare disease. So as per the result, the experimental exception performs the best in terms of F1 cross score. For the ADAM and RMS Pro, optimizer highest performance is for RMS ResNet 50. Now, if we talk about the recall score of all 3 optimizer, ADAM, RMS Pro, and SGD, then VGG16 and DESNet 169 appear to perform consistently well. Exception and DESNet 169 show a significant drop in recall. ADAM optimizer generally provide the highest recall score across most of the model. SGD has the lowest recall score for the models such as insertion V3, DESNet 169, and it is a best choice for this architecture. If we talk about the accuracy of the models for all 3 optimizer, then the models like VGG16, ResNet 50, Exception, DESNet 121, and DESNet 169 all achieve highest accuracy, which is around 90% for all 3 optimizer. And the ADAM optimization often achieve the highest and near highest accuracy across the different models like VGG16, ResNet 50, and insertion V3, and DESNet 121. If we talk about the lowest accuracy, then the SGD particularly for inception V3, we are getting the lowest accuracy, and it is the limitation for deep learning architecture. Now, for the conclusion side, this study is basically utilize the transfer learning for the early diagnosis of a breast cancer, and it uses the various pre-trained model with a multiple evaluation matrix such as F-score, recall, and accuracy to test the performance and its robust methods. As per the experimental result for the ResNet 50 and VGG16, output of a model is 99% accuracy and 93% and 89% recall respectively. So for the medical diagnosis problem, more focus should be on recall, which is highest for VGG16 with ADAM optimizer, which is 99%. And different models show varying recall score across the three optimizers. Consistent highest performance is in terms of accuracy. We can recall or regardless of the optimizer. Adam may be the more effective in the optimizing certain models, and RMS probes tends to perform better than the SGD in several cases. So thank you. This is from my side.
Thank you, Ms. Pandya. Basically, your work deal with the diagnosis or the prediction?
Diagnosis, sir.
Diagnosis means actually it is a life-threatening topic because it is very, you can say, many Indian women are suffering from these diseases, and your work is dealing with the diagnosis.
Yes, sir.
So what I expect is there any uh, prevention can be possible, means you can develop your model accordingly so that the disease should not be happen with any woman, like early prediction we can say.
Hello, sir.
Like symptoms, based on the
Hello.
symptoms.
Hello.
As you are studying in this area, that's why I'm asking you a question. Is there any early symptoms so that the causes can be, or you can generate the alert for such a woman, so she
Sir,
goes
one of my co-author, Mr. Hemant Yadav, want to give the answer
Hello.
of this question.
Hi, sir.
Yeah.
Am I audible?
Yeah, perfectly audible.
Actually, sir, in this particular domain, we are in touch. We are supposed to have some collaboration with the domain expert, like what kind of the data set we can use for the early detection or the prediction of the disease based on certain symptoms earlier. So right now that work still is in process, like with a domain
Yeah.
expert.
Because what happened, suppose actually your system will be classifying whether the woman is suffering from the breast cancer or not.
Yes.
Is that clear?
Yes.
Yes,
Right
sir.
now it is just identification that what
Means
is.
it is being supportive to the alternative opinion, means suppose any
Yes.
doctor says ki you are suffering from the breast cancer, but suppose your system say ki yes, you are also suffering from the breast cancer and stage is like this one, that will be the alternative classification you can say about the breast cancer. But
Yes, sir.
what I suggest ki if you are studying on the symptoms and you are contributed to the early prediction, so that it may be a curable. Otherwise, suppose it will be crossing the stage 3 or the 4, then it is very difficult to survive that patient.
Yes, sir. Yes, sir. We will go for that aspect also.
And basically, as you are using the deep learning approaches, so I found in your data set there are approximately only 700 records are there.
Yes, sir. For the earlier stage, we have taken the 700.
Approximately 675 or something is
600.
there.
Yes.
Yes, here
Yes.
there are the 720 patient,
Yes.
686 patients with complete data.
Yes.
So when we go with this deep learning approach, now we should have at least more than 2000 sets, and within that 2000 set it should be a balance, means number of positive cases and number of negative cases should be approximately somewhere they have to be 60 70 or like that, so that your model will be well trained. Otherwise, suppose it will be a bias, means number of negative records are more, then your model will not be trained accordingly.
Sure, sir. We'll take that aspect into the consideration for the further students.
Okay, that's all from my side.
Okay, thank you, sir.
All right, thank you, Anil, for your presentation. Now I'd like to invite our next presenter. Next, we have Juhi Nathani, and she's going to present on fake signature detection. Ruhi, you may please proceed with your presentation.
Yeah, hi, am I audible?
Yes, you are audible.
Okay, I'll just share my screen. Just a second. Okay. Hi, is the screen visible? I just want to confirm once.
Yes, it is visible.
Okay.
You please proceed.
Okay, so good afternoon, everyone. So the topic of our research was fake signature detection. Now, we all know that forgery of signature remains a prevalent issue in the previous sectors such as banking, legal, and government agencies, leading to financial losses and even legal complications. Now, many properties of signature may vary even when two signatures are made by the same person. So, detecting a forgery becomes a challenging task. Besides, a manual verification is prone to errors and biases and is time consuming. Hence, we have come up with an automated solution for it. We propose a fake signature detection system which uses VGG16 for image feature extraction and CNN for the verification part of the system. The hybrid of these two aims to synergize the strengths of both the components, providing a robust and accurate solution for the fake signature detection. Now, coming to the literature review, in the domain of signature verification, the utilization of deep learning models, particularly CNN and VGG16, has emerged as a forefront methodology due to their proficiency in feature extraction and pattern recognition. Moreover, the exploration of generative adversarial networks, that is GAN, is generating a synthetic forgeries has introduced a novel approach to training signature verification models. Now, the data set that we used for this project was a customized data set, which was built using 200 signatures, both 200 real signatures and 200 forged signatures. The operational flow of the system is designed for the user friendliness and the efficiency. Now, this is the proposed workflow. So the workflow of the system is as follows. The first step is the user input. The user first uploads a JPG or a PNG of his or her handwritten signature in the system, and then the system employs VGG16 for the standardization of the images. The convolution layers of the in the VGG16 act as feature extractors and standardize the dimensions of the image for faster and better pre-processing. The third step is the verification. Now, for the verification part of the system, we have used the CNN model. The CNN is employed to differentiate between genuine and the false signatures. Through the process of training on a diverse dataset containing examples of both genuine and fake signatures, CNN learns to generalize the features and effectively classify even the unseen signatures. This is the proposed architecture, which is a blend of both VGG16 and CNN, where when the user first inputs his signature, the architecture involves two parallel CNN and VGG16 models. The feature extraction is performed on the input signatures, and the extracted and standardized image is then forwarded to the CNN part of the system. The CNN then works on the verification part and then gives the output whether the image of the signature is a forged one or a real one. This is the workflow of the system. Now, as you can see, that first you can upload the signature that you want to check for forgery from the user interface that is mentioned over here. Then the uploaded image goes into the verification folder. The verification folder is trained to classify the image as real or forged. When you upload, these are the examples or screenshots of the working model. So as you can see that first, if a real signature is uploaded, it detects that the signature is real, and if it is forged, a fake signature is detected. Now let me share with you the timeline of the project. Now first we tried to implement this project using GAN. Now GAN is generative adversarial networks, but unfortunately we did not get the required results and the accuracy obtained was only 50%. Now to enhance the accuracy, we decided to use VGG16 for the feature extraction and the verification part. Now, when we employed VGG16 for the entire project, the accuracy obtained was only 55.8%, which is very less than expected. Hence, we came up with then we noticed that VGG16 works better for the standardization part, but did not work well for the verification. Hence, we decide to employ a blend of both, that is VGG16 as well as CNN, which gave us an accuracy of around 94%. At the end of the project, we decided to make a user friendly UI, and so that it can be used by people from many walks of life. Now this is basically the different accuracies that we obtain, and it is a differentiation of all of these three. As you can see that the accuracy obtained in a blend of VGG16 and CNN was the best. Hence, we decided to adapt this in our system. Now, the application of this system is beyond is beyond the counts. Now, it can be used in banking as well as in banking, finance, in the legal and forensics as well. It can be used in schools and colleges to check for the attendance and the signature, if it is genuine or is it forged. So these are some of the references that we used. So that's all from my side.
Yes, Juhi, you're studying somewhere, or you're pursuing your MTech?
No, I just finished my bachelor's in information technology.
Okay, from where?
Thadomal Sahani College of Engineering.
Mumbai.
Yes, Mumbai.
Okay. So, Juhi, basically, your work that will be a signature verification. What are the existing technologies or the methods nowadays in banking or the insurance sector they are using? Have you gone through that?
Yes, I did. Like most of them don't have an automated system. They generally use a manual system for the same. And though there are quite a systems which can there is people check for patterns in the signatures.
Okay.
So they use for matching patterns to check if the signature is real or forged.
Okay. So over the time, is there any variation in genuine signature? Because at your age, your signature might be today it may be a different, and after 10 years it may be a different. Is there any variation you have found in your data set?
The data set that we have used includes signatures from people of different walks of life. That it includes signatures from the people of our age, as well as signatures of the people who are 50 plus. Like we have also taken into consideration the signatures of our teachers, for example. So
So have you found any variation
the
in the
variation,
pattern?
yeah, the patterns are different from signatures to signature.
That's why I suggest you, instead of supporting to only the verification of the manual signature, why not you go with any biometric, means if in your project suppose you have embed any biometric device, IoT device, then it
Okay.
can support to your project. It is your
Yes.
undergraduate project.
Yes, sir. This was.
It is your undergraduate project, na?
Yes.
So supporting to the existing, because what happened, your signature verification topic is too old,
Okay.
and there are basically many work has been carried out on this topic. So the innovative part is like that. Suppose you are going to be just like you are using a hybrid approach for the GAN and the CG16. So similarly, if you use the certain ensemble learning model for with the IoT device with your GAN model, then it will be more beneficial for your project. I think so. What is
Yes,
your
sir.
opinion about
Yes,
it?
sir. I agree completely. We will surely take that into consideration.
Yeah, because what happened? Signatures might be varied because I remember when I was at your age, my signature is strokes means pattern is different, and today they are different.
Yes, sir. I agree. Okay, sir. Yes, sir. We will work on that definitely.
But my biometric are same. At the age of 20, my biometrics are same. Today is also same.
Yes, sir.
So this is my suggestion. And what have you compared the space and the time complexity of the GAN with your GC16?
So the GAN is it is a very heavy technology to implement. So it
No,
takes a lot
with
of
respect to
time.
the time and the space complexity. Now,
Okay. So I did
these are
not,
the algorithm, na? Basically, these are
yeah,
the algorithm.
yes, sir. The GAN was taking a lot of time and the accuracy obtained was not worth the time it was taking. Hence, we have shifted to VGG16 and CNN.
With compared to the space and the time complexity, you should compare your both the work, okay, and your
Yes, sir.
hybrid too. Whatever the hybrid model you have developed now, based on that, check out the theta notation.
Yes,
Okay,
sir. Yes, sir. Thank you, sir.
thank you.
Thank you, Joey, for your valuable presentation. Now I'd like to invite our next presenter. Next, we have Akash Kumar Sinha, and he's going to present on heart disease prediction using different machine learning approaches. Dear author, you may please present your.
Hello. Hello, I am
Yes,
audible.
yes, you are audible.
Let me share my screen. My screen is visible.
Yes, your screen is visible.
Okay. So, good afternoon, sir. So, myself, Akash Kumar Sinha from Jain University, currently from Bangalore. So, my topic is heart disease prediction using different machine learning approaches. So, these are the contents we are discussing. So, coming to the abstract. Today, heart disease remains one of the leading causes of death worldwide, posing a significant burden on both patient and healthcare systems. So, to accurately predict heart disease is crucial for early intervention and prevention, which can ultimately save lives and reduce healthcare costs. Despite advances in medical technologies, early prediction remains a challenge due to the complex and the nature of the disease. So our research aims to address this challenge by developing a machine learning model to early detect the disease. So this is the introduction problem statement in which we have discussed the ability of traditional method to analyze complex pattern present in diverse health data and frequently limited, which is traditional method is limited, so that so we have proposed a machine learning model. We have compared 3 to 4 machine learning models so that we conclude that random forest comes forward in predicting the this disease. So coming to the so this is the data set we have taken. This data set is a standard data set which is available on the Kaggle, in which total entries are 8,763 with 26 features, including patient IDs, cholesterol, blood pressure, etc. So these are the literature review we have done throughout our research, which includes physiologic in 2016 and 2019, etc. So coming to our algorithms, these are the different algorithms we can use for this research, but I have done linear regression, logistic regression, KNN, and random forest and decision trees. So this is the methodology in which we have first collected the data set, then pre-process the data, which includes the pre-process the data, which includes the cleaning the data, and then feature learning and splitting the data, then feature selection, algorithm selection, then model, we have trained the model, then model evaluation, then hyperparameter tuning, then model validation and deployment. So coming to the first algorithm, which linear regression. So in this linear regression, which models the relationship between a dependent variable for like one or more independent variable. This model predicts a risk score and threshold can be set to classify individual at risk and not at risk based on the score. So now second, coming to the logistic regression part. So in this, estimate the probability that a given input belongs to a particular class or not. So it uses the logistic function to map the predictive values to a probability between the 0 and 1, which can then be threshold to make a binary decision. So, coming to the decision tree and random forest part. So in this, an assemble method that improves the accuracy and robustness by averaging the prediction of multiple decision tree. It reduces the overfitting and handling complex interaction between risk factors effectively, but can be less interpretable than a single decision tree. So now KNN is simple and easy to implement, but it can well with a well-level data set. It is particularly useful when the decision boundary between classes is not linear. So in this, KNN algorithm calculate the distance between the new data point and all the point in the training data set. It then assigns the labels based on the majority label among the k nearest neighbors. So this is the summary of our findings, which includes various machine learning algorithms were evaluated for heart disease prediction, in which random forest outperformed the other model, providing the highest accuracy due to its ability to handle complex interaction between features through ensemble learning. The study highlighted the significance of selecting relevant features such as age, cholesterol levels, and lifestyle factors, which are crucial for improving model accuracy and reliability in predicting heart disease. So now coming to the conclusion part. So our research demonstrates the significant potential of leveraging advanced machine learning technique to predict heart disease with greater accuracy. By identifying critical factors and defining predictive algorithm, we have taken important step towards enabling earlier diagnosis and more effective intervention strategies. The implication of our findings extend beyond just improving prediction accuracy. They also offer valuable insight for healthcare providers in preventing measures and treatment for at-risk individuals. Thank you, sir. That's from my side.
So Akash, have you implement this project?
Yes, sir, it's during our academic year, so we have given a project. That's why we have made a research on that also
Okay.
with the help of
So
our faculty. Yes.
which platform you have used?
What's the
Programming language, which programming language or platform you have used to implement this project?
sir? Python.
Python you have used.
Yes.
What exactly the role of NPy and in that coding?
Sir, can you
Have
repeat?
you used the library NPy?
Yum, NumPy. Yes, sir. So,
What is the purpose of that one?
NumPy provide like efficient way to store and manipulate the large data set like health records that is used in the predicting the heart disease, like different features. It scales or and normalize the which are essentially which is an essentially steps before feeding the data into machine learning models.
Akash, So for the linear regression and for logistic regression, what exactly the difference you have found?
So like in the linear regression, it's work well with the label data. Like its features is accompanied by uh, output, and in logistic it's a map with the 0 and 1.
Thank you, Akash.
Okay, thank you.
Thank you, dear presenter, for your valuable presentation. Okay, now next we have Aditya Kalam, and he's going to present on securing data beyond encryption, a comprehensive review of steganography techniques. Aditya, you may please proceed with your presentation.
So is my screen audible, visible?
Yes, it is visible, and your audio is completely audible.
So good morning, everybody. Good morning, Dr. Ranjit Gandhi, sir. I'm Aditya Kadam. My co-authors are Siddhi Pardesi and Abhiram Joshi. Our topic for research is data which is a comprehensive review of steganography techniques. So what is steganography? Steganography is basically the art of hiding messages or different images uh, in its different forms, such as audio, video, or image forms. So the importance of steganography is security and provide confidentiality and integrity to the communication. Basic applications of steganography include digital watermarking, confidential communications in military and intelligence, and secure online transactions. Uh, talking about the early evidences of steganography, it was recorded by Herodotus that Histiaeus sent a slave uh, and sent a message tattooed on his head to the Miletus city. And upon shaving its head, the message was revealed to the people in the city of Miletus. So this was the earlier evidence of steganography. It was in around 484 BC. So it was a long time ago. So classification of steganography techniques including image steganography, text steganography, audio steganography, and video steganography, in which the image steganography is most widely used and is the most efficient way of steganography, we can say. It involves embedding a secret message in an image. The secret must be an image or could be a text. Audio steganography, although can have a video and video steganography can have an image or an audio. So it is a combination of both audio and image steganography. Text steganography includes encryption, which is basically scrambling of text, and the disadvantages of text steganography is that it is quite noticeable that there is something hidden in the image. So the parameters with which the efficiency of a particular steganography technique is calculated is dependent on its capacity, the amount of data it can be hidden inside of it, the robustness, resistance to different image processing techniques such as cropping the image, compressing the image, or expanding. The imperceptibility, which is how well the message is hidden, and there is no distortion after hiding the message in the original image, and the complexity, the level of complexity in the algorithm. So this is the basic steganography block diagram, which there is here we have used a symmetric key. The encoder and decoder are using the same key for encoding and then decoding. Media is the stegno image which is sent through the communication channel, and the art of finding the or attack on the steganography is called steganalysis. So there are basically two domains of image steganography. The first one is the spatial domain, which involves manipulating the pixel values in the so basically an image is made up of millions of pixels. So the pixel has RGB value, which by varying the intensities of these values, the intensity of the color is changed, the value of the color is changed. So by changing the least significant bits of these pixels of these individual pixels, we can hide the messages in an image, so that there's no much of distortion in the actual image, and we can also hide hide a message or hide a different image in a particular image. So this is the spatial domain. The transform domain includes converting the image first of all in frequency domain, and then converting those frequency coefficients, the least significant coefficients, to in such a way that a message can be hidden inside the frequency domain. So the spatial domain has an advantage that it is simple and less complicated. Also, it has greater capacity as compared to the transform domain techniques. The transform domain techniques are comparatively complex, and but they have the advantage of robustness, and the images are not that much distorted as compared to the spatial domain techniques. Yeah, popular algorithms, spatial domain, which is a least significant bit replacement, which involves just replacing the least significant bit. For example, here we have 00011. So by replacing the last bit, which is the least significant, we can embed one bit of message in it. And we know that an image contains of millions of bits. So comparatively, a bigger message of large capacity can be embedded in a single image. So there is this second LSB matching technique, which does not involve directly replacing the image, but first it is checking the current value of these bit. If it is same, then it is not changed, and if it is different, then it is slightly increased by one or decreased by one according to the requirements of the message. So it involves less distortion as compared to the least significant bit replacing method. So this is the domain. This kind of transfer take to convert the spatial domain into frequency domain, and those frequency coefficient DCD coefficients are changed according to the message, and hence the embedding process takes place in that way. Steganalysis is basically an attack on the steganography. It involves detecting the message which has been steganalized. Along with steganography, steganalysis is also a crucial part in cryptography and network security. So this is just some, these are some rows and caps from our critical analysis table. These are just 4 of them. We have reviewed about 20 of review papers, research papers, and came down to the conclusions of their advantages, disadvantages. So for example, here in spatial domain, there is the technique called canny and fuzzy edge detection with LSB substitution. So canny and fuzzy edge detections are algorithms to just detect the edges. It is said that steganography is less noticeable when it is done in an edgy image rather than a smooth image. The smooth image is more attackable to the impressibility of the image. So, and these ELSB embeds only messages only in the blue component. So it is again uh, better for the camouflage of the image, camouflage of the message, and less distortion in the final image. LSBM is least significant bit matching again, which checks the checks if the bit is matching the message, and if it is not, then it would be increasing or decreasing the pixel frequency by one, or decreasing it by one. Transform domain IWT is inverse operates on integers instead of floating point values, so it is less noticeable for the viewers. And disadvantages of transform domains are mostly they are more complex algorithms compared to other spatial domain techniques. Future scope of this steganography review paper is that we have a plan to select a particular technique, especially the transform domain techniques, because they are very complicated, and it is very crucial to get them done in at least less complicated way. And so we'll try to take any particular technique and try reducing its complexity, so which is the main advantages of discrete transform techniques. So this is the acknowledgement. I like to thank Dr. Rupesh Jaswal, who was I'd like to thank my fellow companions, Siddhi and Abhiram.
So Akash, it is basically a review of all the papers you have studied up till now.
Yes, sir. Aditya.
So have you used any review tool for comparing this paper based on the certain advantages, disadvantages, and the techniques?
Sir, I actually read the papers, the abstracts, and then concluded. I actually also used AI. With the help of AI, I just uh, could get the main essence of the paper. Rather than reading the entire paper, I could just get the main technique used and the disadvantages and advantages of those particular techniques.
Okay, so what is my suggestion? If you like, then you go with the Zotero, then there will be a Mendeley, then there will be a SciSpace. These are the very good review tools nowadays are available, and these are open source. Zotero is open source, then what we will call it is a Mendeley, Mendeley, Mendeley is very good tool for reviewing the paper. You can
Okay, sir.
annotate your PDF papers, as well as you can compare your based on the algorithmic approach, based on the data sets they have used, based on the accuracy of their paper or the future scopes. So from the future scope, you can get the research gap within the selected papers, and they are being online, means anywhere wherever you go, this paper will come with you. If you registered on this website, Zotero, then Mendeley, then it will be beneficial for you. By
Yes,
the
sir. It
way,
will be.
go to their first slide, the title slide. So it is a securing data beyond encryption. What do you mean by beyond encryption?
So the encryption techniques involves scrambling of messages, or the text messages just shuffled.
Yeah, that is the definition of the encryption.
Yeah.
But
So why my paper focus on why steganography is better than these encryption techniques, because steganography is not noticeable at the first place that it has been it has been carrying some confidential messages inside it. So encryption, we know that there is something hidden inside the message, but steganography, we don't know that. So that is why.
No, you mean to say, as you know, there will be RSA algorithm, there will be SHA algorithm, and they are encrypt the data based on the particular bits,
Yeah.
128 bits or the 28 bits, like that. So,
Yes.
in that sense, you have used the word beyond.
So by beyond, I mean that just steganography is not less as noticeable as encryption for the attackers. It is not related to any algorithms in particular about
Okay.
encryption.
Thank you.
Thank you, sir.
Thank you, Aditya, for your valuable presentation. Now, moving forward for the next presenter. Next, we have Neha Rathod, and she's going to present on securing health data with blockchain. Dear presenter, you may please proceed with your presentation. Neha, are you here? Okay, might be she's not available in this meeting. So moving for the next, Andrew Samir Verma, and he's going to present on sentiment analysis on Indian stock market using stock tweets, machine learning approach.
Hi,
Samir, are you here?
yeah, I'm here.
Yes,
Let me
please
share
go
my
ahead.
screen.
Yeah.
Is my screen visible?
Not yet.
Not yet.
Yes, now
Now it is
it is
visible.
visible.
Yeah, sure. Okay. Hi, this is Dandu Samir Orma. By the way, thanks for the introduction, Harsh. Today I'll be presenting on the sentimental analysis on the Indian stock market using a stock tweets. So this is the agenda for today. And starting with the introduction, as you all know that the social media is one of the major source of getting information around the world, not only about the stock market, any information. But when we especially come to a stock market, we can also see the information about the stock movements, whether what I meant by information about the stock movements is whether it's a bullish or bearish. So in our paper, in our project, we have created a labeled data set. We have manually created a labeled data set, which consists of a tweets about the Indian stocks along with its momentum, that is whether it's a bullish or bearish. The type of data which we have taken is especially from the IT and the banking sector, as they're volatile. Even a significant change or a minor change in this market might be volatile in such scenario. So in this paper, we'll be using some natural language processing techniques along with the sentimental analysis method to train our data set and classify whether the stock trend might go up or down. In our case, we have used two different algorithms. One is a random forest, other being a ANN method, artificial neural network. So what motivated us to go through this, come to this project is that, you know, that many people has their second source of income by investing in the stocks. But there are people who are very new to the stock market and wants to earn more. But on that note, they'll make many mistakes. So to overcome that problem, we have created this project, knowing that so that it helps the user to decide what position for them to sell or buy for a particular stock. So this actually reduces the mistakes, and also it doesn't it also reduces the risk of getting lost. Now, our objective is actually to identify the forecast uh, that is classification, whether it's a bullish or bearish of a company using a sentimental analysis based on the financial tweets. So as I mentioned before, we have created a manual data set. where we have a tweets about the Indian stocks and its momentum, whether it's a bullish or bearish. This data set, as we have extracted manually, since we have extracted manually, there might be a lot of unwanted data or a noisy data. So to do that, we will undergo the pre-processing method. In this case, we have used the NLP pre-processing NLP pipeline to pre-process the data, and using this, we'll train it using a model, whether it might be a ANN or random forest, to distinguish between whether the stock might go up or down based on the tweet given. So this is the literature survey. These are the papers which we went through to come and do this project. First, we have a bird-based stock market analysis. This paper actually gave us a information that there is something called stock tweets, where we have tweets about the stocks from many experts, whether it will go up or down. In this case, he actually used the Kaggle data set. That too, it's a predefined data set which is available in the Kaggle from 2009 to 2011. So what comes a challenge here is that he has that actually the data set is actually available in the Kaggle, and also it is about the American stocks. But we are actually focusing on the Indian stocks, so we don't have any other choice. So we went for the manual web scrapping using Python by using a stock market APIs, that is stock tweets API. So similarly, we got to know how to pre-process the data after getting a data after doing a data collection. So we actually read this paper and got to know that there is something called NLP pipeline. Using that, you can actually clean the data efficiently so that it can predict the sentiment properly. Similarly, we have went through these two other papers too, where they have used the other algorithms such as Naive and SVM model. Based on their accuracy, they actually went for stock market prediction, but we are actually are into a classification problem where whether it will go up or down. This is especially suitable for the option trading. So this is the NLP pipeline which I was explaining before, and also you can say it as a data processing pipeline. First, the the data set which we had will push into this NLP pipeline. After pushing it, what it will do is first it will remove all the unwanted data. Like we just need a statement so that it should predict whether it's a bullish or bearish. So we'll remove all the unwanted, like URL, emojis, special characters. After that, we have something called stop words. We'll also remove that. It can be an article or adjective. Removing that will not actually affect the meaning of the sentence. So we'll also remove that. Then we'll go under the stemming and lemmatization. Stemming and lemmatization is basically converting information into its base form. Whether, let's think a stock might be increasing, you can actually convert it to increasing as up, so that for classification it be more convenient and we'll get a more accurate results at the final end. So after that, we'll be vectorizing it. And this was the thing which I told you in previous slide. And this is our overall design part. So we'll once the data set which we have created was pushed to pre-process data, then we'll train it with some classifier model. Classifier model in our case is ANN and random forest. Using that, we'll train it. After training it, we'll actually give some real-time tweets so that it'll give a output whether it's a bullish or bearish, so that they can actually the buyers or sellers can actually see that output and do the necessary action. So this is the distribution of the tweets which we have done. That is our data set. These are the companies which we have taken data set from. As I mentioned you before, we are primarily focusing on the IT and banking sectors as they are volatile. So this is how the data set looks like. And this is how the data set looks like. We have multiple companies like ICICI Bank and Nifty 50 and TCS, and its tweet and its sentiment. And this is how the outputs looks like after it was pushed to the data pre-processing pipeline. So once the data set was pushed, first we have to encode the sentiment. So to encode the sentiments, we have placed a bullish as 1 and bearish as 0, label bullish as 1 and bearish as 0, and we have cleaned the body, the tweet body, which I told you after stemming. After stemming and lemmatization, we'll get a clean body, removing all the stop words. We'll get a base meaning of the sentence. Based on that, it will vectorize it. And this is the word cloud of the tweets which we have in the data set. And these are the results which we got for the random forest classifier. And the accuracy which we got is actually 71%. And even the precision and the recall, we had a same percentage, that is 71%. And this is the ANN accuracy, the results which we got. So starting from the loss distribution, we have actually went through up to 120 iterations, that is epochs, and out of which as it goes on increasing, the loss distribution has increased. So automatically we can also see slightest bit of accuracy has also been decreased. So what we have done is that we have stopped at 10th iteration, and actually we have stopped at the 10th iteration and given a real-time tweets and to classify the output. This is the results which we got at the 10th.
Sorry to interrupt you, author, but you have last 1 minute.
Yeah. This is the results of the 10th iteration which we got. We got an accuracy approximately 80%. Similarly, we have a precision of 78%, recall it of 81%, and F1 score of approximately 80%. And this is how we manually taken the real-time tweets and checked with the random forest algorithm and with the ANN model. And coming to the conclusion, we actually by training it with random forest and ANN, we got to know that the ANN gives a better accuracy than the random forest. And this also can be taken to next level by using algorithms like RNN, especially when you can use a LSTM model to classify the output. Then social relevance, as I told you before, that this
Okay, Mr. Verma, first of all, you have studied very well and you have presented your topic also in a well manner, and the slides you have prepared, that are really nice. Thanks for that. Now, what you have chosen, that sentiment analysis for the stock market based on the financial tweets, right?
Yes, sir.
So how do you implement your work?
I didn't get
In
you.
which programming language you have implemented your work?
Okay, it's using Python, sir.
You are using Python. Which IDE you have used? Jupyter or
We have went through a collab.
Google Colab you have used. Very good, very nice. So whatever the graphs you have plot for that purpose, which library you have used?
The one which I have showed you, that this one, sir.
This one will be your accuracy graph. So
Okay.
which library you have, Python library you have used for displaying this graph or creation of this graph?
Okay. Actually, there
Because
is
at
something
one
called
axis you have taken
matplotlib.
the accuracy and another axis you have taken the tweets.
Yeah, we will actually get the all that from the what do you say from the classifier itself. After that, we have used matplotlib to place these two graphs. That
Okay,
is, one is the train and the one is the test.
okay. So have you how you have decided कि random forest gives you a better result? Have you compared it with any other techniques?
Actually, in this case, actually, I got ANN is accuracy is better than random forest, sir. So,
Okay.
okay, the reason why I actually chose these two algorithms is because first I've tried it with the SVM model.
Hmm.
Uh, since yeah, this is the last data set, first of all, I didn't get a better accuracy compared to the random forest, and it's a to be honest, it's a trial and error method, sir. So I've tried using SVM. So random forest, I got to know that the random forest and the ANN model, artificial neural network, is wonderful. That is wonderful models for large data set and to determine the complex patterns. So we have went through this random forest and ANN rather than the SVM model.
Okay. Somewhere you have mentioned in your slide कि you are using the labeled data.
Yes, labeled data. Yes.
What do you mean by labeled data?
It's a supervised learning method where you'll be having information about the weights and about the what is it about, whether based on the tweet it will go, it is a bullish or bearish.
So your output will be in a form of bullish
Bullish
or
or bearish.
bearish. It is a
Yes.
binary output.
Yes, it's a binary output.
It is a binary output. Thank you.
Thank you, sir.
Thank you, Samir, for your nice presentation. Now moving forward for the next presenter. Next we have Jayu Jain. He is going to present on text-driven image synthesis, optimizing prompts with ChatGPT in DF, GA, and Frame. Dear presenter, you may please proceed with the presentation.
Hello.
Yes.
Yes, I am sharing my screen. Uh, Is the screen visible?
Yes, it is
Yes, it
visible.
is visible.
Okay, so good afternoon, everyone. Myself Jayu Jain, and my co-authors are Vatsal Mehta, Gayatri Joshi, and Karan Chopra. So I am here to present my topic, text-driven image synthesis, optimizing with ChatGPT using a DFGAN framework. So so basically, what is our problem statement? So our primary goal was to learn capabilities of different GAN models and also to implement and get images from the text descriptions, to generate images from the text descriptions. So this is the literature survey. So basically, what we found is that existing models, they actively try to enhance the image quality, but they fail to align with the text description. So here we are with the DF-GAN that aligns well with the text description as well. So the methodology we used is it's a COCO dataset that has object images in it, and cube dataset which has environment related images in it. So what have we done till now? So initially we have started with the basic GAN model. We tried MNIST dataset on it. And after that, we tried stack GAN, which has a flower dataset on it. But they didn't give well results. So we proceed with the DF GAN, in which we used COCO and the BERT dataset. So why we chose DF GAN, or what were the limitations of the previous two GAN models? So previous two GAN models were very costly in the sense they were taking a lot of time and lot of GPU. Other than that, stack GAN was highly dependent on the previous generators. So DF GAN only uses a single generator and a discriminator, but stack GAN was using two discriminators and two generators. So even if the previous generator was faulty or something like that, then the future will also be impacted by that. Also, other than that, as I mentioned, they were not very much aligned with the text description and were actively focusing on how well the image can be formed. So basically, this is the block diagram of our DF GAN. So first we will feed it with the text encoders, convert our text into a text encoder and feed into the model. And we have a series of up blocks. So what does up block does is it basically keeps on increasing the pixels of the image. So initially it will go with 2 by 2 pixels, then 4 by 4, then 8 by 8 up till 256 by 256. And after that it will go through the discriminator, which will have our which will calculate all our losses and everything. So it has a adversarial loss. So basically what happens is it focuses on how well the image is and also how well the image is aligned with the text. And if the image is not very well aligned with the text, it will re-go into the iteration. So for this, the dataset we have used is of COCO and image dataset. So around 28,000 dataset, the size of the dataset is around 28,000, and we have iterated up to 350 epochs. So this is the basic implementation of our project. So we have also calculated the quality score. So we tried it without GPT. So it was giving a little bit low quality score. So what we did is whenever a user gives a specific prompt. So in this case, it is a snowy mountain landscape with a clear blue sky. So what we do is we take this prompt from the user and we give it to the chat GPT, which converts in a more definite way that can be understandable by the by that particular data set and which is suitable for the data set. So after you can see the like difference in the quality score. It was 344 before and now it's 380. So this was it. And the future scope is that so as of now our projects is capable of generating images of environments or object related things. So we have to include human images as well. And other than that, the way we are evaluating the quality score, we can try working on better evaluation. And these are some of the references. Thank you.
So, Mr. Jayu,
Yes.
is there any alternative for this GAN model, GAN model?
So basically, there are different versions of GAN model, but
No, version no. Is there any alternative model? Is there?
so yeah, there is one more model, OpenAI's DALI model.
OpenAI is used by the Chat GPT, and what else you have
So
conveyed?
so we came across that DALI model. Other than
DALI,
that, DALI model.
DALI model. Okay.
Yes.
So your input will be a text or something
In,
else?
input will be a text.
Input will be a text, and
Yes.
your model will generate the image.
Yes.
And what exactly in that residual block? What is the use of that residual block? In your system architecture, I found that there will be a residual block.
This one.
Yeah.
So basically, it just like from the previous image, it just calculates the difference, how well the image quality has been. So it just calculates that, the residual block.
How? Because
Uh,
all the things are being residual means what? The things that will be not used,
yes,
that we will call the residue, na?
yes, yes. I think my co-author Karan can better answer this part.
Please, Karan.
Yes, sir. Am I audible? Hello.
Yeah.
Hello. Am I audible? Hello.
Yes, Karan, you're audible.
Sorry, I'm not able to hear properly. Yes, sir. Am I audible now?
Yes,
Yes,
you are
Karan, you are
audible.
audible.
Yes, sir. So as Ravi said, like residual blocks are generally used to like improve the quality and the stability of both generator and the discriminator blocks. I could not hear what question was after that.
Okay, that's all from my side.
Okay. Thank,
Thank you, dear
thank you,
presenter,
sir.
for your presentation. There's a last call from the paper titled Securing Health Data with Blockchain. Is there anyone who's going to represent this paper? All right, so I think so there is no one. Okay, so as we have completed all our presentations of this session, I sincerely thank our authors for their excellent presentation and great contribution in this session, and all our participants for being a part of this international conference. So I hope this session was informative enough for all of you. And we, on behalf of the team of ICT4SD, thank you for your support during this version of the conference and previous all 8 versions of the conference. And we will be happy to have you all in the 10th version of the conference in 2024 Goa. Sorry, 2025 in Goa. Okay. So all the presenters will be getting their digital certificates through email within 2 working days. Whether all the papers have been already forwarded to the stranger. So publication will take at least 6 months for the publication process. So kindly cooperate with the team ICT4SD 2024. I also thank our session chair for chairing the session. Sir, there is one token of appreciation to be a chair on behalf of Global Knowledge Research Foundation. Yeah. So here's a token of appreciation to be a chair. Thank you, sir, for your presence. And sir, if you want to say something about today's presentations.
Thank you. Thank you, Harsh.
Okay. So in the last, I would like to request you all to turn on your camera so we can capture good memories of this virtual conference. I request other participants if they can turn on their cameras. Great. Thank you, everyone. Thank you for your support and thank you for your valuable presentations. And thank you, sir, once again for your presence.
All the best to the new researchers as well as ongoing researchers. Complete your work as early as possible. My best wishes with you. Thank you.
Thank you, sir. Thank you.
Thank you, sir.